Basic wired, wireless, small home office networks. In this lesson, we're going to discuss small office, home office network topics. We're going to discuss IP addressing. So let's go ahead and get started by starting off with IPv4 IP addresses. IPv4. IP stands for Internet Protocol, and V4 or version 4 stands for version 4. IPv4 was the primary version brought into action for production within the ARPANET back in the 1980s. IPv4 has been around for many, many years and it's in heavily used today. It's a 32-bit address that identifies the device on a network. An IPv4 address is typically written in decimal digits, formatted as four 8-bit fields that are separated by periods, like in the example below. This IP address is 192.168.1.200. However, if you break that down and look at it in binary, this is how that same IP address looks in binary. The 192 octet, it's really broken down to 11000000. Then you have your dot, and then you have the 168. The 168 in decimal format reads 168, but in binary, it's actually 101010000, and so forth for the rest of the IP address. So that is the binary format. That's how computers communicate and talk. And that's how able to use the binary format to calculate our IP addresses and routing and many other features that comes with our routable IP addresses. So let's break this IP address down a little bit further to define as far as its structure. So 8 bits equals 1 byte, which equals 1 octet. So our 32-bit IP addresses actually are 4 bytes. Since 1 byte is 8 bits, the maximum decimal value for each byte is 255. And what that means is if you take one of those octets, and you'll see that it has ones and zeros in the binary format. And as you start adding all those ones, if one's octet was all ones, it will be a value of 255. So that's what our IPv4 addressing scheme is built on. Now, IPv4 has limitations. Actually, when this first came out, the projected number of IP addresses that would be available using the IPv4 format was around 4 billion. And at that time, they thought that that would be more than enough IP addresses for devices in the world. And that was at that time. But as you know, as the years went by, we've had IoT devices, all these technologies, and all these devices that uses IP addresses. So we've coming close to being exhausted or having all of our numbers in use. So there will have to be a new format for IP addressing scheming. And that's what brought on the IPv6. Now, IPv6 is a total different way of structuring our IP addresses. It uses 128-bit addresses. IPv6 is what the vehicle that's going to carry us throughout further in all our growth. So IPv6 is the most recent version of the Internet Protocol IP. It's designed to supply IP addresses and additional security to support the expected growth of all our connected devices in IoT, manufacturing, and emerging areas like autonomous driving. So IPv4, like I said, had about 4.3 billion IP addresses, whereas IPv6 is based on the 128-bit addressing. It can support up to 340 unidecillion or 340 trillion addresses. That's like having multiple IP addresses for everyone on the planet. More than enough IP addresses that we'll even need today and tomorrow using the IPv6 format. So IPv6 provides us more than enough global unique IP addresses for every network device on the planet. In addition, IPv6 has other benefits like stateless address auto configuration, optional NAT, which is network address translation, and easier administration with DACP v6 or version 6, and also improved quality of service with flow labeling. Now, IPv6 uses hexadecimal digits for addressing, and we'll look at that in a moment as far as the breakdown of IPv6. But before we do that, let's break down the structure of IPv6 because IPv6 has a network portion, which is the first three octets. Then it has a subnet ID for identification, and that's the next subnet. And the last four subnets, it would be the host section. Now, just like we did IPv4, let's look at IPv6 in that format. IPv6 broken out in the binary is what you have here. And as you can see, it's quite a long number. 128 bits equals 16 bytes. Now, let's talk about IPv4 private and public IP addresses. What is a private and what is a public IP address? So basically, all the devices that we have on our internal networks uses private IP addresses. These are IP addresses that do not route on the internet. We use them privately on our networks. Now, IP addresses overall are managed by the Internet Assigned Numbers Authority, or the IANA, which has overall responsibility for the Internet Protocol IP address pool, and by the regional Internet registries, the IRRs, to which IANA distributes large blocks of addresses. Now, your private IP address exists within a specific private IP address range reserved by the IANA and should never appear on the internet. So, your 192.168.1.200 IP address will never be a routable IP address on a public internet or on the internet. So, there are millions of private networks across the globe, all of which the devices use private IP addresses within certain ranges. So the IANA has dictated certain private IP address ranges to use on our devices. And these ranges are in a class A, B, and C. And as you can see here, these are the ranges for private IP addresses. Now, on the contrary, we have also public IP addressing. Public IP addressing is in ranges outside of the private, and these are global reachable IP addresses. They are assigned by your ISP, and these are IP addresses that actually are routable on the internet. You can find these IP addresses assigned to web servers, devices, routers, firewalls, anything that has an internet facing presence on the internet. You would put a public IP address on it. And you may think, why do you need a public IP address? Um, if you have a web server called, let's call it google.com. Google.com, if you translate that IP address to an IP, it's a publicly facing IP address. Anything that you need to be found to be routable or found on the internet, you give a public IP address. So again, public IP address are global reachable, assigned by an ISP, and they communicate over the internet. Whereas a private IP address is an internal local reach, it's just on your internal LAN, assigned to local devices, and they communicate just on the local network. So, configuring a private IPv4 IP address. So, when you're configuring an IP4 address, you're going to go to configure the IP address in one of two ways, either static or dynamically. So, in the static or manual setting, your IP address will be given to you by your network admin, and you'll go into your configuration of your computer to assign that IP address, and you will select use the following IP address, and you would put in the IP address in the IP address field, and the subnet mask is what determines what network you're on. You would put that information in. And you'll also be supplied with a gateway. And your gateway is really the gateway to your router or firewall or the route to the internet or the rest of the network. Without that, you would not be able to travel across your network. So you would put your default gateway IP address in. And finally, you'll put your DNS information in. Now, the DNS translates to IPs to domain names, and we'll cover that in another lesson. But basically, that what defines google.com to an IP address. So that's your static settings for your IPv4 IP address. Now, if we look at configuring an IPv6 address, it's the same format. You would use the following IP address and you would put in the information supplied to you your IP address, your subnet prefix, and again, that defines what network you're on, your gateway, and your DNS information. So that's how you statically assign an IPv4 and IPv6. However, Now let's look at DHCP IP address. DHCP, Dynamic Host Configuration Protocol, will receive an IP address from your DHCP server, and it's done automatically. The only thing you would do is hit Obtain IP address automatically, Obtain DNS server automatically, hit OK, and you will receive that information from your DHCP server. That could be a dedicated server, or it could be a router or firewall with that role. And the same thing would be done for an IPv6 IP address as well. You'll receive that information automatically. Now, what happens if that DHCP server or that service is not available? You'll get what's called a API-PA, or automatic private IP addressing IP address. So when that IP address is not received, the operating system by default will issue you a Class B IP address assignment. And this IP address assignment is going to be between the range of 169.254.0.0 to 169.254.255.255. It's a non routable IP address, meaning when you get this IP address, you will not be able to travel across the network, nor would you be able to get out on the internet. And you'll only get this when your operating system has not received an IP address within a certain amount of time from the DHCP server or service. And this is, if you were to look at your IP address in a Windows format, this is how it's going to look. It's going to be a 169.254. Whatever, whatever. And it'll be a 255.255.0.0 IP address. And again, this is not a routable IP address. You will not be able to get out to the internet nor connect to other devices until you have your DHCP server issue you a proper IP address to route across the network and out to the internet. So, in this lesson, what we discussed and covered is IPv4 versus IPv6 structure. We talked about IP addressing, the static and the dynamics, subnet mask, gateway. We talked about automatic private IP addressing and public and private IP addresses. Thank you for staying with me for this lesson, and I will see you in the next lesson.